Good afternoon, good evening. You guys get to listen to us for the last part of the day. I apologize. You guys have been hearing a lot about grease, a lot about SIUs, CIUs, OWSs, grease interceptors. So now you guys get to hear about water reuse. So real quick introductions. I'm Matt Bulow. I am the Water Reclamation Division Manager for the Cheyenne Board of Public Utilities. I'll pass the mic over here. This is Bryce Dorr.
Good afternoon, Bryce Dorr. I'm engineer with the Board of Public Utilities. Have done a lot with the organization around our reuse system, at least from a theoretical standpoint. I didn't get to be around when kind of some of this originated, but we'll do our best to keep it somewhat interesting for you. Go ahead. So this is the most words I've ever put on a slide before, but I thought that it was pretty cool if you look at the date, 1951. It's always been known that water in the West is scarce, and we need to do everything that we can to conserve it and use it wisely. And I think Cheyenne had pretty good foresight in terms of kind of moving into the water recycle industry. And really, the community has really taken to it. There was a lot of effort put out in the beginning in terms of public outreach. This whole concept of for every gallon that you have, if you reuse it, now you've got two. It's really hit home. Our population has gone up. Our number of customers have gone up. However, our total amount of water use has stayed flat, really, since we've introduced the recycled water and some other tiered rate changes with it as well. So it's kind of the background.
All right, now you guys get to listen to me some more. All right, so reuse started back in 2007, offset 500 acres per year. So the reuse that we do produce at our Crow Creek facility is Class A reuse. So who in here besides Kent Loader and these two up front know what that means? No one. Okay, so what that means is we have to meet certain criteria through Wyoming DEQ that is 2.2 CFU units or less. Right now we're running usually zero or non-detect. I guess that is zero or non-detect. Zero non-detect on the reuse system right now. Our reuse system usually runs from March 16th to about November 15th every year. There's a reason behind that, but I don't want to bore you guys to death with that. Currently we use it on parks, athletic fields, cemeteries, schools, the VA, Airport Parkway here uses it. But we use it to offset, like Bryce said, our source water. Real quick, this is an overview of our system. So you'll see here, this is our Sherrard water treatment plant. That's where the fresh water is made. We're on the other end of it. Here, where's the laser pointer on this? What'd I do? There we go. Where's the laser pointer on this thing? Anyway, imagine, if you will, this is our Crow Creek facility, and right there is our Dry Creek facility. For those of you that wanted to tour tomorrow, the Dry Creek facility, I apologize, we're no longer doing tours out of concern for COVID. So real quick, I'll do an overview of both facilities. But the purple lines that you see here on the map is basically our road map to where our reuse is used. We pump from our Crow Creek facility down here that you see up into the Prairie View Pond that we use for a holding tank, and then the city takes it over and they use it to irrigate. Quick overview of what we do as far as water reclamation. We have two water reclamation facilities. Our Crow Creek facility, where our reuse is located. The design capacity of that plant is 6.5 MGD. We're about half of that, about 3.25. Dry Creek is rated at 10.5 MGD. We're about half, about 5.5 MGD. One cool thing about both our facilities is Crow Creek is an MBBR. Who in here knows what MBBR is? I'll be asking a lot of questions, and I'll start pointing fingers. What's an MBBR? There we go, excellent. Dry Creek is an IFAS. Anyone knows what an IFAS is? Right on, excellent. So as far as I know, we are the only municipality in the United States that have both. Why is that cool? It's cool because engineering firms come in, they're designing a wastewater treatment plant. It's a one-stop shop. We had a municipality from Oregon come in a couple years ago. They flew into DIA, they drove up for the day, visited Crow, visited Dry, and they went home that night to their families. So we're kind of a cool one-stop shop. People can see the benefits of both. Tying this into this conference is, what do you guys think is better, IFAS or MBBR, as far as slug loads? As far as from an industrial user or for grease discharge or a slug load, IFAS or MBBR? IFAS, absolutely. Reason being is that you got your return activated sludge, and that's why we have our dry creek plant. The majority of our flow goes to our dry creek facility for treatment. So that's a quick overview of the tour that was going to happen tomorrow. If you guys like more, I can leave my contact information or things at the end of the slide. Feel free to give me a shout, send me an email, and I'll gladly help you guys out. So with that, the reason that we're up here is reuse. I think I broke it. Oh, nope. There we go. So this is an older drawing of our Crow Creek facility. So if you bear with me real quick, I'll kind of walk you through the process. Up in the upper left-hand corner, we have our influent pumping station. We'll use that to bring water into the facility. One cool thing about Crow Creek is that we can actually shut the influent pumps off. All that flow is going to go to Dry Creek. We can't do the same for Dry Creek. So Dry Creek's kind of our baby, so to say. No one has favorites, but Dry Creek's our favorite. But with Crow Creek, brings the water in. We'll go through the pre-treatment, 2 primary clarifiers. From the 2 primary clarifiers, we go into a splitter box. This rectangular object you see right here is our MBBR. So I have our anoxic zone for denitrification, and then we go into our aerobic zone for nitrification. And then from there, we go into the secondary clarifiers. From there, we go down to the UV disinfection building. And then from right here, we got Crow Creek right here. There we discharge our waste treatment. So if we were just talking wastewater, everyone would be gone, happy, and you guys can go play pinball. But we're talking reuse. So from there, we actually go from our UV disinfection building into what we call our secondary disinfection building. So we have 2 lines that come off the UV building, goes into the secondary disinfection building. From there, we'll inject sodium hypochlorite into it for disinfection. So we're disinfecting with UV, and then we'll disinfect the sodium hypochlorite. It'll sit in that wet well, and then when we need to make water, what we call making water, we'll actually take that water with our transfer pumps, pump it up to this building here, which is our filter building, aka the reuse building. We're going to coagulate it with aluminum sulfate. From there, we go into 2 trains of sand filters. The sand filter will remove all the big heavy particles, and you'll get to see our lift pipes here on a couple slides coming up. Remove all the big particles. The reject water will actually go back to the head of the plant, start all over again, go back through the whole process. The good water will actually go into a purple pipe, which will cut across the property into our old south flume that was used for a trickling filter. It'll fall all the way down that flume into a splitter box, into our 2 reused holding tanks that used to be the trickling filters years and years and years ago before the MBBR was there. From there, it'll sit in those tanks until we get a call for water up at our Prairie View Pond. There's a golf course here in town that we use for a holding tank. That's what we use to irrigate the ponds or the parks, the fields, the VA, the cemetery with. But from there, we'll pump it up there with our high service pumps, and then the city takes over from there. So here's a quick overview of what I just described. So imagine, if you will. UV disinfection building, wet well right here, 3 transfer pumps, goes into our mixer with our alum, into our 2 trains of sand filters, splitter box down into the 2 tanks. As soon as we get a call to water up at Prairie View Pond, we kick on our high service pumps. We then inject more sodium hypochlorite into it, disinfect a little bit more. Then we send it up to Prairie View Pond, and then we got our 4 pumps on the outside that the city will use to irrigate the property around town. Quick overview of our UV system. I know Jake and Nate and Ken will probably get sick of me hearing this, is redundancy. Got a lot of redundancy between the 2 facilities. We like to rob Peter to pay Paul from time to time, especially with our UV, clarifiers, blowers, you name it. We got a lot of redundancy between the 2. Anyone in here ever seen a UV system? Yes, cool, excellent. So this is just kind of a quick model of what we have at both facilities. It'll go through just disinfecting the waste stream before it goes on to reuse. Here's a picture on the right side. We do, like I said, we disinfect basically 3 times with the reuse system. We UV, and then we inject sodium hypochlorite twice, once at the CTP pit, and then once when you're sending it up to the pond. Picture on the right is a picture of 2 of our 5,000-gallon tanks, sodium hypochlorite, and then on the left side is our tanks for the alum. What do you guys notice in those pictures? They're identical. We got redundancy. So we got to steal a piece of equipment off one to rob the other one. We can do that. Redundancy. Real quick, this is our lift pipes for our sand filters. Has anyone in here ever seen this style of sand filter lift pipe ever? Besides Jake, Nate, and Kent, and Vicky. No? Okay, so this is a little bit different of what you're used to. So in the top right corner, you got your influent pipe. That's going to flow down in through the sand. You got a manifold that's going to flow all the water up. You have an internal weir up there that's going to flow over the water. The water that goes over that weir is the good water. Water that flows up through the sand on the inside, that top little box right there, we call that reject water. Like I said, we like to reuse. So we're actually going to take that reject water, send it back to the influent pumps, and pump that back through our process. Here's a picture of our old splitter box. This is original 1947. It's held up pretty well. The water will actually come down that flume, go into the splitter box. You can kind of see in that picture is the reuse tanks. And then there's another picture of the reuse tanks. That's just the old trickling filters. We just repurposed them. Each reuse tank can hold up to 1.5 MGD, so 3 MGD total. And we can just kind of let them sit. I believe Prairie View Pond's at 4 million gallons, so if we get really crucial, we can actually drain both of these tanks and fill up the pond. And here is a picture of our high service pumps from these 2 tanks. We'll kick either 1 or 2 of these pumps on to pump up to Prairie View Pond. On the outside of this building where these pumps are located, there's a manhole. That's where we actually inject the sodium hypochlorite once again, just making sure, we don't want a little kid up there playing soccer or anything like that to get sick once we're pumping up the water that's already came from the waste stream. These pumps are rated at 1,750 gallons a minute, so it fills up that pond pretty quick. And with that, I'm turning over to Bryce.
Thanks, Matt. So that's kind of the present. This will be our transition here. Just a quick chart kind of outlining some key water quality parameters when related to use and reuse for irrigation water. As you can see, we kind of live in the slight to moderate level nationally, which when you live in Wyoming makes it actually probably not the best. So we have run into some of those issues. It's hard to grow plants here. You stress them out with the water that's not the best for them. It makes it a little harder as well. So in terms of that's where we're at, and in order to make that a little bit better, we do have some opportunities that we can look at either from our treatment trains or, kind of working with the community in terms of, acidifying the water, kind of going out and looking at water softeners in town or people using them where they actually need them, doing some of that, see if we can change some of that, those monovalent ions that cause issues for the plant growth. Gypsum soil amendments, kind of at the parks and things that could help with some of that stuff. Again, over nutrients can cause an issue on site, and then believe it or not, just how you spray the water has a big impact. So a lot of times we see if you're using the big spray kind of nozzles and that salted water gets on needles and things like that, it'll kill the trees off. Whereas if you had something that's more of a drip kind of system, that they do react much better in those situations. So a lot of opportunity moving forward. It kind of goes back to that first slide that there's always opportunity to be more efficient with things, and the water is finite, so we can only get better at using what we already have. So speaking of that, this is kind of just a quick chart here that shows our reuse water supply and demand. Along the y-axis, you can see our average monthly flow. Along the x-axis, averages for, based out broken per month, with the kind of green being our secondary effluent from our Crow Creek facility, which is the one that has the reuse plant, and then the light blue, which could be, expanded upon, and that's our downstream plant. So, and then the gold shows essentially how much reuse water that we're currently using. So even as someone who, I said is kind of above the game, at least in Wyoming, we still have a lot of room to grow there. So essentially what we're running into, though, is if you look at this top line, part of our water conservation efforts is that you only irrigate at night. So what that does is that puts a huge peak hour demand load on the system. So we actually need to provide a lot more water at any given time than we can treat. So really what that tells us that we really need to start looking into for our system is to increase our storage so that we can get through that overnight watering period without really having to expand all of the treatment capacity. And then here recently we kind of did a reuse study where initially our board was curious about going straight to direct potable reuse. We kind of pushed back and said that's kind of a last straw for most communities. There's a lot of things that we can go do in the interim. So we ended up taking this approach on this study that we tried to build kind of a building block, how you build one project onto the next in order to get to that DPR in the future if we ever needed to get there. And we kind of came up with these different pathways that kind of build on top of each other. And at the time, it was just kind of happenstance that the one that ended up to be the golden answer here was supplying a local refinery with reuse water. That's kind of fallen apart because they have changed their process to use a lot less water. So the cost for infrastructure on their end, it doesn't make a whole lot of sense anymore. So now we have to find the next future for our reuse water. And it's kind of starting to point towards this data center destination that has become Cheyenne, Wyoming. We're seeing a lot of development interest in this front. I think a lot of these customers have a desire to operate green, to do some things that benefit. They're high water users, they know it, and they know that water is scarce, especially in the areas that make sense for them to operate, kind of drier, cooler, those types of areas. Wyoming, again, the wind here is great for them. So lots of open space, cheaper land. So we're seeing a lot of this, but it does kind of have a catch-22 when it relates to the data center. Big summer volumes. So if we could use reset, that would be a nice offset for us in terms of our seasonal distribution in terms of water demand. But at the same time, they fill these things up, cycle them, and then dump them. So we see potentially big slug loads that can hit our plants as well as our sewer conveyance collection systems, causing some capacity issues in the pipelines as well. And while they are relatively clean, they do have that high TDS, which is very bad on the irrigation side that we kind of talked about a little bit earlier. So again, the other thing is that as you build reuse, it takes a lot of money to expand and improve upon our treatment and distribution, as well as the upcycling that occurs on these types of applications with the industrial cooling. So really, we would need to have some sort of sink where we could, drop out some of that salt at any given time. Now, the good news is, though, that they do seem to be willing to be funding partners most of the time. So it could be an opportunity where, the two needs do come together. And that is one challenge that we have kind of run into with the reuse system, is that it's really hard for us to just go build something not knowing if anyone's going to use it. Outside of the kind of big customers, the 1-2 kind of smaller developments, they just can't put the money into the infrastructure required. So finding those customers that we can really work with and beneficially be mutually beneficial, it's half the battle. Being creative with some public-private partnerships, those types of things, and then working with our codes and regulations, both locally at the state, not quite as advanced as some other states in the region probably in that area, and then finally looking at the rate structure, making it beneficial for folks to look into this outside of just kind of the responsibility side. The monetary side is always gonna have an impact. So really that's kind of where we're at, and I think it's it's having that partnership that I'm sure a lot of you, I don't know really what any of you do, so I apologize with that. I do my best, right, Vicki? But understanding that relationship with the customer and how you have to help each other out, but still kind of make sure that everything's getting taken care of. We're finding that to be part of this issue as well. So I think with that, we're open to any questions you might have.